Hello, everyone, and welcome to the last lecture of chemical safety. So today we're going to be wrapping up our discussion by talking about good laboratory techniques. However, as usual, I'd like to start off by talking about a famous safety incident. So this incident happened in Texas Tech in 2010, where there was uh, two students who were working with nickel hydrazine perchlorate, which essentially is a high energy compound, which is a fancy chemist way of saying explosive. And they were trying to work through a new technique to synthesize their compound. And to do so, they were working outside the hood without goggles, without advisor permission, and working in with amounts of the material that were just far too large and far too dangerous. And while trying to purify the compound, one of the students was using a mortar and pestle and managed to pretty much blow off his hand. So again, there's a lot of things that usually need to go wrong for you to essentially get in trouble. So today's going to be walking through a lot of the individual things that you can fall back on to help minimize the likelihood that you're going to get in trouble. And that when you do, that there's always a good fallback to minimize the amount of damage that might happen. So one of the most effective things you can do to prevent a disaster is just practicing good lab technique. And this means that this is one of the big things that your time here as Truman should help teach you, is what's good lab technique and what's bad lab technique. And good lab technique will generally help prevent any sort of major problems. And one good source for what you should do while doing any given synthesis or purification is to refer to what are called standard operating procedures. So these are typically published or well-respected procedures for how you can do a given process. So a lot of these are going to be published in journals, but it's also a fair number of websites that are developing about spreading standard operating procedures that can be trusted and help minimize any sort of danger. And one of the reasons why this big move started was with such incidents that I've been talking about over the last several weeks, including the Texas Tech explosion and the Sangji incident of setting herself on fire, because almost all of these incidents started with somebody who wasn't following SOP. In addition, even if you are following a standard operating procedure, one of the biggest things you should make sure to be aware of is your surroundings, because what may have been a good standard operating procedure in one location might have some problems when you try and implement it, because it turns out that, your hood might be a little bit too close to, say, an ignition source or a flammable materials cabinet. Or you need to make sure that you remove, say, all organic solvents away from an area where you may be doing a high heat extraction. So being very aware of your surroundings and what potential dangers are near you can be really important. And very much associated with this is try and make sure that you keep all of your surfaces clean, because it's very easy for you to spot a hazard that might not be there because it's there as an impurity on the in your surroundings. And a good example of this is if you say go down to the analytical lab, where there's been several dyes that have now permanently embedded themselves in several of the countertops or even the balances, and have been known to start spreading to, well, clean clean containers of chemicals. And a lot of this has been because people haven't been watching out to keep all of their surfaces clean before and in between uses. And again, one of the big things that I've noticed is often a problem is if you're working in the hood, make sure that you keep the hood sashes at the appropriate setting. So essentially, do not move the hood sash too high. Otherwise, it doesn't act as a safety hood. There's insufficient ventilation or airflow inside the hood, and you don't have a glass protector sitting in place in case something explodes or spills. And I've actually seen these hood sashes literally save lives. So those stops on the side of the hoods are there for a reason. You should never move the hood sash above the safety setting unless you actually need to temporarily move in or pull out a piece of equipment. And again, one of the big things is I can't go through all of the good lab techniques and guidelines that you're going to need for your entire life as a chemist. So most of the things that I'm going to suggest you do is make sure you follow the specific guidelines that are going to be provided to you by your instructors. As one of our major goals is just teaching good lab technique, and part of that is good, safe lab technique. And again, one of the big things that is always worth noting is while it might be kind of the last step of protection, always make sure that you wear the appropriate PPE. If you don't, well, then you can start getting in danger when something does go wrong. But I do want to emphasize what perhaps the single most important lab practice you'll ever encounter is. And that's you never, ever, ever work alone, because Murphy's Law says that things will go wrong, and they'll go wrong when you least expect it. And so even if you are just coming into the lab to say, move over a column or end a distillation, make sure you have somebody with you, just so that they can go for help in case something does happen. No matter how simple the procedure is, the lab is an inherently dangerous place. So always make sure that someone at least knows where you are and that you have someone there for backup. And we'll talk more about this later. Now, one of the other important things is, again, this PPE procedure, because again, every lab procedure requires slightly different protective equipment. So this has been a topic that we've talked a lot about lately in the here at Truman, and this is the difference in between, say, safety glasses and splash-proof goggles. And it's worth noting that both have their place. Safety glasses are essentially for use when you're working with mechanical dangers. So if I'm, say, working on a centrifuge or, say, with some sort of piece of equipment, safety glasses are going to be my dominant form of protection, because what I really need is something impact resistant in case, say, something comes loose or I have any particulates flying around. So this is more or less the minimum level of safety gear that you should have in a chemical lab. However, the moment you start working with actual chemicals, and the moment actual chemicals are out, no matter how safe they might seem, you should pull out your splash-proof goggles. Because even if you're working with something, say, as simple as a vinegar solution, I probably have a week's worth of pain prevented by the fact that while playing around with a dilute acetic acid solution that ended up spraying all over me, I was wearing splash-proof goggles, despite the fact I was complaining about splash-proof goggles right up until that very moment. They're there for a reason, and if you have to choose in between one form of eye protection, always choose the splash-proof goggles, because this is essentially what you're going to need at some point in your chemical career. And so if you have to choose for one, choose the one that's more likely to do you good under a wider range of circumstances. Similarly, it's also very important to be aware that not all gloves are created equal. And we saw this earlier when we were talking about Wetterhahn, who had a single drop of dimethyl mercury permeate through a latex glove. While latex gloves are great, and they're they're one of the more common forms of PPE or hand protection, the major reason why they're so commonly used is they provide very good dexterity, which is a very important feature when working in a lab, and they're good against most aqueous solutions. However, the problem is that latex is by its nature an organic polymer, which means they're actually fairly poor against most organic or non-polar materials, as as they can actually be dissolved um, by certain organic solvents. And something similar happens with nitrile gloves. Because again, they're also very good with dexterity, very cheap, good against aqueous solvents, solutions, but poor versus organics. And I've actually had several pairs of nitrile gloves dissolve on me when I had to work with chlorinated organic solvents. And that's kind of a disturbing sight the first time you watch a glove more or less melt on your hand. So again, despite the fact that we use these so commonly, the major reason why is they're good against a lot of the aqueous systems we typically work with, and they're very cheap and easy to use. However, a lot of times we do need something that actually can resist organic solutions. And for that, you might need something more like neoprene, which can still have good dexterity and physical properties, much better chemical resistance, though again, not perfect. But as a result, it's often several times as expensive as typical nitrile or latex gloves. And so if you're going to be spending a lot of time working with a chemical solution, one of the things I encourage you to do is go on to our Blackboard page and pull out the full list of what gloves are good against what sort of solutions. So again, I have a small selection of that available here. And some of the things you have to watch out for is something like, say, a simple cotton glove provides no chemical resistance, and while it might be good for, heat or cold resistance, in fact, what it will often do is ending up absorbing a lot of chemical solutions and holding them against your skin, which means that sometimes something like a cotton glove may be more dangerous than no glove at all. And you see very similar behaviors out of leather. So again, leather gloves are commonly used in lab, mostly because they're very good against heat and are also very good when we're working with electrical systems or sort of harder physical damage. But again, one of the things you have to watch out is they can absorb chemical contaminants and hold it against your skin. So again, one of those things you have to watch out with some of these common glove types. And again, as I said, nitrile and latex are very good and low cost. One of the things you should watch out with latex is you may have an allergic reaction. So if you ever find yourself using latex and getting red skin or hands, watch out, you may be experiencing an allergic reaction. And one of the reasons why most labs have moved towards nitrile. And again, one of the things to watch out is that both of them are fairly poor against a lot of our organic solutions. For example, nitrile is specifically bad against benzene, methylene chloride, and a lot of ketones. Now, something like neoprene is going to have a much better chemical resistance, and again, good physical properties, but it is also much more expensive. And again, when we're talking about the importance of fabrics, one of the other things you should watch out for is what your other clothing and protection is besides, say, just gloves and goggles. So when working with chemicals, one of the things I do want to emphasize is to try and avoid any loose hair. So this can be long beards or long hair, as they can very easily catch on physical hazards, or they can also end up absorbing chemical species. But also one of the things you should watch out for is loose clothing and jewelry. So, for example, one of the specific things you should watch out for is the use of bracelets, whether they're cloth or metal. And a good example of this is if you're working with, say, something like a cryogenic liquid, like liquid nitrogen. As liquid nitrogen is quite cold and non-polar. And so there are have been several incidents where people have been wearing cloth bracelets or cotton bracelets, which, when exposed to the liquid nitrogen, essentially wick up the liquid nitrogen and hold it against the wrist of the person who's using it. And again, this is a good way to end up with very severe frostbite all over your wrist or hand. And many other incidents have occurred with, say, even metal jewelry doing something very similar. So again, make sure that you're very aware of any jewelry, and try and keep it as close to your person or under your clothes when possible. Similarly, also try and maximize skin coverage, as this prevents the amount of skin that's open to, say, exposure from acid, and because I'd prefer all of you to not get acid burns. Similarly, when working with shoes, one of the things that you should try and make sure is that all of your shoes are made out of either leather or synthetic fibers, as this will help prevent, say, damage from several chemical species. And most importantly, a lot of the cotton shoe covers can essentially hold chemicals against your feet. And so essentially covering your feet with these leather synthetic fibers is going to have much more chemical resistance and be less likely to result in injury. Also, one of the things that I want you to be very aware of when working in a lab is remember those reactivity tables we've been talking about. Making sure that you try and keep in mind how those various chemicals can interact. And as I just illustrated, be very aware of, say, what sort of chemicals may also interact with the chemicals in your clothes. For example, keeping a lot of nonpolar toxins and things like liquid nitrogen away from cloth, which can be fairly chemically absorbent. One of the other things you can do to help prevent any sort of danger is to make use of a lab coat. Lab coats are highly encouraged when working in most chemical labs because they offer protection for both chemicals and flame. They often form a shield against any sort of chemical exposure, but also very importantly, if a chemical spill, say, occurs and it is absorbed by, say, a cotton lab coat, one of the big things to remember about most lab coats is they're designed to be quickly removed so that you can quickly shed any sort of chemical exposure and remove yourself from harm. And similarly, in case it catches fire, it's much easier to, say, remove a lab coat than most clothing. But also they act as a protection barrier for whatever clothes you have. And this gives a good general reminder of, if you really love a shirt, never wear it into a chemical lab, because eventually it will get damaged and destroyed, and Murphy's Law pretty much says the more you love it, the more likely it is to get damaged. And if you don't believe how much damage a chemical lab can do to your clothes, I highly encourage you, say, coming in and taking a look at mine or Dr. Lamp's lab coats, and you'll notice, if you're looking for it, all of the nice little chemical burns that are located on our lab coats. And again, this is, one of the major advantages of lab coats, is kind of as a sacrificial layer. So that happens to the lab coat and not you or your clothes. Now, one of the things I do really want to emphasize before I go is that no matter how well you plan or prepare, sometimes things are going to go wrong. You may even do something exactly perfectly, but the person next to you might not. And there's always unforeseen complications because Murphy says so. So it's important that you're always prepared ahead of time by knowing where all of your emergency response tools are. So make sure you're aware where all the fume hoods are inside of a lab. As occasionally you can have things go wrong, such as a reaction that spontaneously starts emitting toxic gas, which I have seen on several occasions. Also, be aware of where all the safety showers are. in case of any sort of chemical exposure or spill on your clothing, you should immediately go on into a safety shower and start stripping off your clothes to remove the chemical away from your skin as quickly as possible. Also, in case of any sort of uh, exposure of chemicals to your eyes, make sure you're aware of where all the eye wash stations are and flush your eyes for a minimum of 5 minutes straight. Also, make sure that whenever you're working in a lab, you know where the first aid kits are located and all the fire extinguishers. And make sure if you're using a fire extinguisher, aim at the base of the fire and then work your way up. Otherwise, you may be likely to spread the fire. Also, be aware of the location of fire alarms and any exits so you can exit as quickly as possible if something goes wrong. Now, one of the last notes I'm going to leave you on is the first important thing to do if something goes wrong in the lab is actually going to be to stop and think. So this goes against a lot of what our natural instincts are, is to quickly confront or flee, classic fight or flight responses. But if you see something go wrong, stay calm, think about what happened, observe and assess the situation. What's the problem? What are the possible dangers that come from me, say, helping? What sort of unintended consequences do I have to watch out for? For example, if there is a fire in the lab, you should quickly observe where the fire is and where all the flammable materials are that you need to be aware of. If the fire is too close to the flammable materials, your best option is to get away. If it's far enough away from any other ignitable materials, you may actually be able to do something in time. But again, you need to be able to observe exactly what the situation is to be able to plan a quick set of responses that will, first of all, protect people, then equipment. And please try and keep in mind if a chemical is going to pose any further danger. Again, this especially occurs to fire hazards or chemical fires. And again, one of the most important things I want you to be very aware of, if something happens to the people around you, make sure to note it might be up to you to actually solve the problem, as your partner very well might not be thinking straight. And I will admit, this actually happened to me. I was working in a kitchen. I was trying to clean a microwave a little bit too close to a gas stove, and my sweatshirt caught on fire. And while I was trying to figure out how to put out my sweatshirt, as demonstrated by the fact that I was not thinking straight because I was on fire, my wife was able to quickly come in and say, "What are you doing? Stop, drop, and roll." Because while everyone knows what you should do under an ideal situation, when you're actually confronted with danger, you're often too hyped up on adrenaline to be able to start this stop process. So again, if something happens, make sure that you stop. And if something happens to those around you, make sure that you are willing to step in to help out, because they might not be thinking straight and it might be up to you to rescue the day. So with that said, that brings us to the end of our unit on safety. See you next time for ethics.